Hello everyone, welcome back to 3 Deviations. In today's video of single variable calculus, we will be covering increasing and decreasing intervals. We are picking up all that we need to draw a really good sketch of a graph, and of course we will be continuing this throughout the next few videos. So in the last video, we started talking about finding maxima and minima of graphs and using the mean value theorem and Rolle's theorem to find where our secant line is equal to our tangent line. That was, of course, the mean value theorem. Now we are going to start talking about another area that the derivative is really going to help us in, and that is increasing and decreasing intervals. So we're going to talk about that. And of course, if you haven't been doing a lot of differentiation recently, I recommend you do watch some of my Unit 2 videos so that you are prepared for the video. Let's get started. So let's start by just recalling what the derivative is used for. We use it to find the slope of a graph, or the slope of a tangent line. If I have a graph that looks like that, I can use the derivative to find my instantaneous rate of change. Okay, so my derivative will also provide me with a function. And basically what we can use the derivative for is to say if f prime of x is greater than 0 on an interval, then f of x is increasing on that interval. So if my derivative here is greater than 0, then that means I have an increasing interval. Likewise, that's the same on this interval. Here I'm decreasing, and I'm increasing here. That's how it works. And the same goes for decreasing. If f prime of x is less than 0 on an interval, then f of x is decreasing on that interval. Alright, let's do an example with this. So this is going to be a little bit tedious, but we should be able to get through it. So they are telling us to determine where f of x equals 3x to the fourth minus 4x to the third minus 12x squared plus 5 is increasing and decreasing. Okay, so first what we should do is we should find our derivative and find our critical points. So to do that, we are going to use our power rule friend and our addition and subtraction properties. And that will show us that f prime of x equals 12x cubed minus 12x squared minus 24x. And of course, to make this easier on ourselves, we can factor this, and that will make it easier to find our critical points. So we get 12x times x plus 1 times x minus 2. So now we can find our critical numbers, and that of course is when f prime of x equals 0, and that will give us -1, 0, and 2. Okay, so those are our critical numbers for this function. So now we are kind of going to be solving some nonlinear inequalities here, and we'll be using a sign chart of sorts at our critical numbers. So now we have intervals. So first, we are going to test between -infinity and -1. That's our first interval, between -infinity and our first critical number. So 12x is going to be less than 0, x minus 2 is going to be less than 0, and x plus 1 is going to be less than 0. And of course, that means that our derivative will be less than 0, which means that we are decreasing. Okay. So now let's try between -1 and 0. So 12x is going to be less than 0. X minus 2 is going to be less than 0. But x plus 1 is going to be greater than 0. So that means that f prime of x is going to be greater than 0. Thus, we are increasing on that interval. Now let's try between 0 and 2. 12x is greater than 0. X minus 2 is less than 0. And x plus 1 is greater than 0. That means that f prime of x is less than 0. Thus, we are decreasing on that interval. Finally, we are going to try for 2, infinity, our last interval. 12x is greater than 0. X minus 2 is greater than 0. X plus 1 is greater than 0, and that means that f prime of x, our derivative, is greater than 0. Thus, we are increasing on that interval. So we've made an increasing-decreasing chart here, and this will allow us to better describe the way our graph works. All right, So now let's talk about a more formal test that we can use, and this is called the first derivative test. So what is the first derivative test? So suppose c is a critical number on a function f which is continuous. So if f prime of x changes from positive to negative at c, then f is going to have a local maximum at c. And if f prime of x changes from negative to positive at c, then f is going to have a minimum at c. This is basically saying I'm going to have, if I'm going from positive slope to negative slope, or negative slope to positive slope. Okay, and if f is positive to the left and right of c, and negative to the left and right of c, then there's going to be no maximum or minimum at c. That just means that we're cruising along with our graph. Let's do an example with the first derivative test. So we are going to find the local max and min of f of x equals x plus 2 sine x on the interval between 0 and 2 pi. Okay, so if we take our derivative, we will get 1 plus 2 cosine of x. And we can find our critical numbers, of course, when that equals 0. If we solve with some algebra and trigonometry, we're going to get that our critical numbers are 2 pi over 3 and 4 pi over 3. Okay, so now let's do our intervals. So between negative infinity and 2 pi over 3, you're going to have f prime of x greater than 0. That means we're increasing on that interval. And between 2 pi over 3 and 4 pi over 3, f prime of x is going to be less than 0, so we are decreasing. And between 4 pi over 3 and infinity, f prime of x will be f prime of x will be greater than 0, so we are increasing. So now let's find our values. So we are going to find that f of 2 pi over 3 is equal to 2 pi over 3 plus root 3, and f of 4 pi over 3 is equal to 4 pi over 3 minus root 3. So we found our values there. All right, so that was our video for the increasing and decreasing intervals of a function. And of course, we're going to be building upon this in the next video. You'll see you then. Goodbye.